Okay, when we do with the regression, when we want to find the best model, so how can we find the best model? We need to use multiple models. So in Orange, it is simple. You just find what are the models that you want to use and then check the performance. So for example, we can use KNN. We call it K nearest neighbor. So KNN looks at the K closest data points in the training set. So K means any number. If K equals to 3, then we want to find the 3 data points nearby the data. So for the regression, it predicts the value by taking the average or weighted average of the values of the K neighbors. There is another kind of model, we call it tree or decision tree. So the algorithm selects the feature that best splits the data into subsets, aiming to minimize the variance within its subset. So we call this is the decision tree regressor. So you can just put the model. Let's say this is the data that I want to use, so I can just connect with the model. I want to use KNN. Then you can put into the test and score. I want to use 3. Then you can put in the test and score. And then at the end, you can check the test and score. And you can do the comparison. So whether you want to do with the cross validation or you want to do with the random sampling. So here you can see the training set size. The training set size means how you want to make the ratio between the training and the testing. So if the training is 70%, then it means the testing will be the remaining. This is 30%. If I select the training is 80%, it means the testing is the remaining 20%. And there is a repetition. So here, repeat, train, and test. So we use random sampling. So they select randomly for 10 times. So this is the cross validation. If the number of folds is 5, then we split into 5 different subsets or 5 groups. If we choose 10, then we choose 10 groups. If we choose 20, then we have 20 groups. So it is not possible because it exceeds the number of data. So most of the modeling, we can just use these two to figure out the model. And then you can check the linear regression or KNN or tree. So how can we select this one? Which is the best model? We need to see the performance. So we need to see the performance. Error rate. The error rate means the MSE, RMSE, MAE, RP. This is the error rate. The error rate means, we want to get the low errors. The lower, the better. So the range is in between 0 until infinite. We don't. It depends on the data. So if it is near 0, of course, it's very good. If it is high value, then it is not good. So if you look at this one, MSE is 2.9, KNN is 2.2, 3 is 1.4. So which one is the best? We will select 3 because it shows the best MSE. What about the other measures, RMSE? Okay, this is also the best among the other two. What about the MAE? This is also the best. What about MAPE? Okay, this is also the best. Then we can choose this model for our AI model. Now, R square. Okay. R square shows that the higher is the better. The range is in between 0 and 1. So the value closer to 1 is the best. So if you see this one, this is high. Okay, then this is the best among the other model. Okay, that's in conclusion, we can say that decision tree is the model that we can use for predicting the sales. And the decision tree, we can look at the tree viewer. Okay, what does it mean by tree viewer? So if you go to the tree, okay, after you complete the modeling, you can connect to one widget, we call it tree viewer. So this is tree, Namu. So it's like tree. And then you can click here, show the details in non-leaf. Then there will be details like this one. So what does it mean? So let's look at this detail. In this case, we have 10 instances. So before I mentioned to you, I select 10 data, 10 rows. So there are 10 instances. And the most significant attribute to determine the sales is TV. So we can see from here, TV. So this is the most significant attribute or the most important attribute to determine the sales. And the average of sales is 12.1. Okay, this is the average, 12.1, with the variance 23.3. Variance 23.3. So plus minus 23.3. It means there is some data which is higher than 12, and there are some data which is lower than 12. And we can see here, there is a condition. There is a condition. If the TV spending is less than 44.5, the predicted sales is about 7.9 plus minus, or we can say the variance is 4.6. If the TV spending is higher than 44.5, then the other factor is radio spending. So we need to check. If the radio spending is higher than 32.8, the predicted sales is about 22.3 with the variance 3.2. Okay, so this is the predicted sales is 20.3 with the variance 3.2. But if the radio spending is less than 32.8, then this is the predicted sales. Now, there will be questions. This might be a question in the exam. I will give you model or I will give you data, and then there is a new data. So company A inform a data as the table below. So the company A will put the budget for TV 66.1, and then they will put the radio with 5.8 and the newspaper with the value 24.2. So predict the sales using the two models. So we have the linear regression or LR, and we have the decision tree DT. So what is the sales? And we can directly fit the numbers into the model. So if you still remember, we have the model in the linear regression like this one. Y equals to 1.85 plus 0.06 multiplied by x1 plus 0.23 multiplied by x2 minus 0.06 multiplied by x3. So we just put the number. What is the budget for TV? 66.1. What is the budget for radio? We put here. What is the budget for newspaper? Then we put here. Then we can do the calculation. We can get the value. So based on the linear regression model, the expected sales is this one, 5.699. What about with the regression tree? So we have this decision tree. How can we know the predicted sales? Then we will check this on the value. The first attribute that split the condition is using the TV budget. What is the TV budget? 66.1. So 66.1, is it less than 44 or higher than 44? It is higher than 44. We go to this section. Next, we will see the condition based on the radio. The radio is 5.8. So 5.8 is less than 32.8. Then this one. So we can say that the prediction of sales by the regression tree is 12.1 and plus minus 1.0. So this is the prediction result based on these two models. Okay. Next section is about the classification. As we learned at the previous section, if it is regression, then the target is numerical. In the previous example, we have the advertising dataset. And the target is the sales, which is numeric. Now, I want to introduce another dataset. This dataset is play golf dataset. Do you play golf? No? Okay. Then let's see. Some people, they want to play golf depends on some attribute. For example, the weather. What is the outlook? What is the temperature? Or whether it is windy or not. So this data is categorical. This data is categorical. This data also categorical. This is the target. This is the decision whether the person will play golf or not. If no, it means the person this person did not play golf. The second person did not play golf. No. So what is the condition? Okay, we will see the outlook. Outlook. Rainy. B. B also tenant. Golf. They don't play golf when it is raining. When the temperature is hot, okay, they don't play golf. When the windy is false, so it means there is no wind. Okay. Maybe because it is raining and the temperature is hot, so people do not want to play golf. The second data, it is rainy, it is hot and windy. Okay, the person did not play golf. But the third data, the outlook is overcast. Do you know overcast? It's like cloudy, gurung, manan something. Then, okay, the person play golf. The temperature is hot. Yeah, the person still play golf. Maybe because it is cloudy. Yeah, maybe it is a little bit no sun, a bit of sea. So golf chimney people. Windy, false. Okay, so this condition make the person wants to play golf. So we have three attributes, which is outlook, the weather outlook, rainy, overcast, and sunny. The temperature, it is hot or mild or cool, and the windy situation, whether it is true or false. So we want to check whether the person will play golf or not. If it is yes, then the person will play golf. If it is no, the person will not play golf. Now, with the same process, with the same flow, we will check another model. We call it logistic regression. So logistic regression. Some people say that, oh, this is regression. Regression, how many? Okay. At the first part, we say it is regression when the target is numerical. But we use logistic regression when the target is category. Okay, please do not confuse. Even though the name is regression, but we use the logistic regression for classification. This is for classification. At first, we will select the data and then we do the model generation. And again, I will do the interpretation and then check some of the performance measurement. I already give a data set in the e-class. I already submit one data set. You can check. Now let's try to open it. Let me open a new one. So I can use file, or you can use CSV file import. Okay, there are two options, whether you want to use file or you want to use CSV file. Okay. Let me just use file. Now I want to open with the golf data set, small. There's a data set here. You will see this data set. Outlook, temperature, windy, and play call. So this role is feature, this role is feature, this role is features, and we need to set up one column as the target in order to make the classification. And you can see this is categorical. So it is for classification. Now let's see the data table. So we have 14 data, and this is the data. We have the play close, outlook, temp, windy. So we have 3 features, and there are 14 instances. So you can do with the feature statistics. So in the feature statistic, you can see the mode. There is no mean. There is no median. Why? Where mean, median, observe? Because all data are categorical. We cannot get the mean with categorical value. We cannot get the median with the categorical value. We cannot get minimum. We cannot get maximum. Okay. Categorical value only have the mode. We can check the most frequent value. And there are no missing values. So we are going to do the logistic regression. So this is the logistic regression. And let's say, yeah, we have one option, regularization type. So it depends on the type. We have the lasso, we have rich, and we have none. So let's just put none. Okay, I don't put any option for the regularization. Because if I put another regularization, then I need to explain that one. So let's just use default. This is none. And then let's check the test and score. And then do this test and score. And then let's check the data table. With the test and score, yeah, you can get another performance measure. So the idea of the cross validation and the random sampling is the same with the regression, but the only difference is the measure. We have the AUC, CA, F1, precision, recall, and MCC. So yeah, we will check the details later. And then we have this data table. If you see this one, this is almost the same with the regression. We have intercept, and then we have the weight for every variable. So what does it mean? When we do with the categorical data, the outlook, how many values do we have? We have rainy, overcast, and sunny. So it means we have 3 values. Because we have 3 values, so we have 3 variables, x1, x2, x3. So if it is rainy, it means x1 equals to 1, x2 equals to 0, x3 equals to 0. What about if it is sunny? If it is sunny, then x1 equals to 0, x2 equals to 0, and x3 equals to 1. Okay. Temperature, we have hot, mild, and cool. So we have three values. Then we have x4, x5, x6. So if the temperature is hot, then it means x4 is 1, x5 is 0, and x6 is 0. What about the windy? There are two values, true and false, x7 and x8. So if the windy is false, then x7 is 0 and x8 is 1. Okay. Now we have the target, yes or no. So we have yes or no. Is this y1? Let's say the y1 is yes and y2 is no. So sometimes we can make two, or sometimes we can make only one. It depends how you want to define it. But let's say we have only one at this moment because it is only two. If it is not yes, then it is no. So if it is not one, then it is 0. We can have the logistic model like this one. Alpha, it means the intercept, and beta 1 until beta n is the weight for its attribute. So beta 1 is the attribute, the weight for x1, beta 2 is the weight for x2, beta 3 is the weight for x3, beta 4 is the weight for x4, x5, x6, x7, x8, and the n with the arrow. X1, x is a value with 1 or 0. Okay. Only 1 or 0. So if it is rainy, then it is 1 for x1. The remaining will be 0. And we can have this model. How to interpret this model? We have the intercept 1.58. We have the overlook, or if the overlook equals to overcast, then we have 15.58. So 15.58 multiplied by x1. If it is rainy, then we have this value. If we have sunny, we have this one. If we have cool, yeah, and so on, then yeah, we can have this formula. It means that if there is a high value, if there is a high positive value, it increases the chance to play golf. So for example, the overcast, the temperature is cool, when the temperature is mild, and when the windy equals to false. Okay. Because those values are positive. The higher value means it is the higher chance to the person to play golf. But the negative value, it decreases the chance to play golf. So for example, here is minus, 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 minus. So it decreases the chance to play golf. Okay, based on this model, we know about the interpretation. Now we need to check how to measure the performance. So we call it as the confusion matrix. So confusion matrix is a useful tool for analyzing how well the classifier can recognize tuples of different classes. So there are some terminology, we call it the TP, TN, FP, FN, and so on. So if the actual class is yes, and when we do the prediction, it is yes. So we call it TP. TP means true positive. So the condition is the person play golf and the AI predict the person also will play golf. Okay, then it means the actual value is play golf and the predicted value is play golf. Then yes and yes. So we have this TP. The person play golf, but the AI model say that the person do not play golf. So the actual class means the real value the person play golf, but the AI say not playing golf. So we call this is false negative. So let's say if the person do not play golf, but the AI say the person play golf, then we call it this is false positive. FP, false positive. The actual is no, but the prediction is yes. And the last one is no and no. Then it means when we know the person do not play golf, and the AI also predict the person do not play golf. So this is the TN, or the true negative. We have P, or the positive samples, and we have N, which is the negative samples. So the positive samples means the number of people who play golf, and N is the number of people who do not play golf. So this is the formula. We have the accuracy. This is TP plus TN divided by P plus N. TP plus TN divided by P plus N. P plus N. We call it error rate if we have FP plus FN, FP plus FN divided by P plus N. We call it sensitivity or true positive rate or recall. The formula is TP divided by P. TP divided by P. We have specificity or true negative rate. This is Tn divided by N. Tn divided by N. We have precision, which is Tp divided by Tp plus Fp. Tp divided by Tp plus Fp. We have F or F1 or F score. It is 2 multiplied by the precision. This is precision. Multiplied by recall. This is recall. Divided by precision plus recall. So I will skip this one, F beta, because we need to have some weight to determine the F beta. Now let's see. In the test and score, we will see AUC, CA, F1, precision, recall, and MCC. So let me just skip MCC and AUC. CA. What is CA? CA is classification accuracy. F1. So we saw from the formula, it was a formula from precision and recall. Okay. Now let's see how we can measure the accuracy. Now you can see the actual and the predicted. So the actual is yes and the predicted is yes. There are 8. The actual is no and the predicted is no. There are 2. So this is the accurate information. The accurate information means when I know the actual condition, So the AI also predict the same with the actual condition. Then the accuracy is 8 plus 2 divided by the total positive and sample, the negative. So the total positive is 9, the total negative is 5. Then we will divide with 14. Then the result is 0.714. Okay. So this is to show about the accuracy. For precision, recall, and the other things, yeah, you can try to measure by yourself. So we can also do with the other modeling. Let me stop here, okay, because you can try to figure out more. I think I need more time to explain this one. Now let's go to the E-class.